Hello guys, in this video we'll be talking about shortest distance between two skew lines. If you have not seen my previous videos, go to the description. I have given the topics as well as their links so you can do the previous videos in this chapter 3D and then come to this topic. Now here we'll be talking about shortest distance two skew lines between two skew lines. Now before doing that, we need to know what are skew lines. What are skew lines? So as I have written here, they are non-parallel and non-intersecting line. Now let's see in two dimension. In two dimension, we had three cases. One is parallel lines. Yes. The other case was intersecting lines. The third case was collinear lines. Collinear lines. Okay. Now in 3D, we will be having skew lines. We will be having intersecting lines. In 3D we had intersecting lines. We found the angle theta between them. Yes. Now another case is they will be parallel. Okay, parallel means they should be on the same plane. Okay. In 3D we'll be having skew lines. Now let's look at this XYZ plane. Now if I draw a line like this which is parallel to XY plane, okay, it's going in this direction. See the direction? Now you see I draw another line which is going like this. Okay, from below that line it is going like this. So do you think ever they will intersect? They will not intersect each other because they are at different heights. Okay, so these kind of lines are called skew lines. Okay, let's look at a pic, it will be more clear. Now see, this is a three dimension. Okay, this is, suppose this is x, this is y, this is z axis. Now suppose I tell you that I draw a line on this side, this one, see, on this plane, and this will be parallel to this plane, right? This will be parallel to this plane, and I draw another line which is going from here, this one. Do you think ever they will intersect? Do you think they will ever intersect? One is going from top, this will be parallel to this axis, this red line will be parallel to xy plane. Okay, so let's see. Now see, I've drawn a line like this. It's going to the bottom as well as it's going to the top. It's moving in crosswise direction, below and up. Okay, let's draw another line. See this line, it's parallel to this axis, this plane, it's parallel to this plane, it's parallel to this plane. Okay, now you look at the diagram carefully, you will see they will not intersect. If I extend these two lines, so this one will be parallel to this axis, okay, and the other one will be going top and bottom. Okay, this one will make it more clear. See the line, the distance between this, you can clearly see that. Okay, so they will never intersect. So these kind of lines are called skew lines. Now as we are talking about the shortest distance between two lines, how do we measure? It is the perpendicular distance between them. We all know that in coordinate geometry class 10 we have done that between two lines the shortest distance is always the perpendicular line. always the perpendicular line. Okay, now look at these two lines. From the previous knowledge we know that we can write line equations like this. So I have assumed two lines. The equation of first one is a1 vector plus lambda b vector. This is the point on the line, this is the vector parallel to the line. Okay, this is another line which has a2 as a point on that. Okay, and b2 as a parallel line. Now look at this diagram. You will clearly see that this line which is passing and this line which is going, they will be closest at this surface, on the surface they will be closest to each other. Okay, so there I have drawn one, there I have drawn this line which will be perpendicular to both of them. Okay, I draw a perpendicular line, and as I said, this is your line 1, suppose this is your line 2. Okay, so in line 1 I will be having a1 point, yes, so I take it here, and in line 2 I have a2 point which I take it here and join them. Okay, now I will represent, now understood, now I will represent this whole situation in the paper, so you should not be confused. Remember, there we have a perpendicular line and we have a line which is joining a2 and a1. So try to relate this and that picture. Okay, so you see I have drawn a perpendicular here, this is the perpendicular, and this is a line joining a1 and a2 which I have already shown there. Now you can see that this line is parallel to this line is parallel to this. Okay, so if I have a line perpendicular to these two lines, they will also be perpendicular to our parallel vectors. Clear? If this is the line, if this is the line perpendicular to this line and this line, okay, and this line is parallel, this line is parallel to this line and this line is parallel to this line, so this perpendicular will also be perpendicular to b1 and b2. Yes, now let's see, if I take the cross product of b1 and b2, I will get a vector which is perpendicular to both of them. Yes, now this is already perpendicular and I found a vector which is perpendicular to b1 and b2, so this vector will be parallel to this vector if both are perpendicular to that. Okay, this is not visible here, okay, but you can clearly see that if this line is perpendicular to this line and this line, okay, then this line will also be perpendicular to this one and this one. Clear? Okay, then after that, if I take b1 cross b2, I'll be getting a vector which is perpendicular to both of them. Okay, this is also perpendicular to both of them, this is also perpendicular to both of them, that means they will be parallel. Okay, so now let's proceed. Now look at the diagram carefully. PQ is the shortest distance. You agree that this is perpendicular to both of them, so it is the shortest distance. Now PQ is perpendicular to L1, PQ is perpendicular to L2. Okay, so if it is perpendicular to L1 and L2, it will be perpendicular to both of them. Yes, now what I do, using this b1 cross b2, I find a vector n is perpendicular to b1 and b2, and if I find that n vector will be parallel to PQ vector, right? So if they are parallel, if two lines are parallel like this, okay, and if I have this vector, suppose this is n, okay, so what I can do, I can find n cap, and this n cap I can multiply with some constant to get this one. We have already done. Do you remember this? vector A is equals to lambda times vector B. For parallel we prove this. Yes. Okay, so this is our B, smaller vector, and I multiply it with lambda to get a bigger vector A. Okay, so this is the concept here. So what I will do, I will find n vector, then I will find n cap, and using this n cap I will find my PQ. Clear? Okay, so we already got that B1 cross B2 is parallel to PQ. Now I am finding n cap. Okay, as I said, I will be finding n cap. Okay, so what is our n? B1 cross B2. From that figure it's clear. So if this is, so this is n vectors, how do we find n cap? N vector by modulus of n vector, right? So which is ultimately this, because n is B1 cross B2. Okay, once we are done, once we found this n cap here, okay, I will multiply that with some constant and assume that it will be PQ. Okay, this D is unknown, so I will multiply with D and then see that it is PQ. D will be finding later. That is what we need to find. Okay, so see what I have written. This PQ is equals to D times n cap. N cap, you know where it is. Okay, so now you see I have written D is the magnitude of PQ. Okay, when we look at PQ, okay, if I represent it with vector, then we need to find its magnitude. Yes, magnitude is important to find the distance. Okay, to find the distance, magnitude is important, so we need to find the magnitude of PQ. So what I have done, so I have taken D as the magnitude of PQ. So when you do modulus of PQ, you can write D. Okay, or you can just write the length PQ. Okay, but here we are finding D. Okay, so distance we are finding, so we take PQ as D. Okay, so now look at this. If I shift this line, this one here, because this is a vector, so vector can be moved anywhere in space, so this will form a triangle, isn't it? So that triangle I'll be making here. You see that AB is this. I have moved that AB here. Okay, so if I ask you what is my AB vector, then what will you say? Can I say A2 minus A1? Because in vectors we have seen, if 2 points are given or 2 position vectors are given, how do we do? Subtract the second one with the first from the first one. Okay, now look here. What I do, I find this theta between them. This theta I'll be finding. So if I have two vectors PQ and AB, so cos theta will be what? We know dot product. If we want to find the angle between two vectors, we use cos dot product. So PQ dot AB by modulus of PQ modulus of AB, right? We will have that. Yes, so see here what I have written. Okay, now AB we already found that this is A2 minus A1, and PQ you can see here, which is D times n cap, right? PQ, the module magnitude of PQ is D, magnitude of AB, since we have not denoted this by anything, so we'll just write AB. Okay, it's the length. Okay, now focus on 2 and this, what I'm saying. In triangle PQA, look here, in triangle PQA, PQA, yes. So if I say what is cos theta, this is different one. Side adjacent by hypotenuse. So side adjacent is PQ vector, and then hypotenuse is this AB vector. Okay, so from this I can get PQ is equals to AB cos theta. Look here, in triangle PQA cos theta is this, and we get this. Now we substitute our cos theta, we substitute our n cap. Okay, we substitute n cap here. Okay, we substitute n cap here, and then we substitute cos theta here. Okay, so see here we add n cap. N cap is what? This divided by this. Okay, and a2 minus a1 is as it is, ab is ab. Okay, and there was ab here, so for that ab I'm writing this. Now pq is a magnitude, right? So I have taken magnitude. So when I take magnitude, I have removed the vector sign. These are yet to be calculated. Okay, so now when I cancel ab and ab, you can see the shortest distance is this. Clear? So this formula you have to remember. Now let's see an exercise example. Let's see an example on this. Now the shortest distance between these two lines. Okay, why I have taken Cartesian one, Cartesian form? See, this shortest distance formula is there in Cartesian form also, but I'm not doing it because if Cartesian form is there, you can convert it to vector form in just one step and then solve it. If vector form is given, directly you can do. So no need to remember Cartesian formulas because already you have lots of formulas in your syllabus. Okay, now see, from this I can write my a vector and b vector, right? See, a1 will be 5i cap plus 7j cap minus 3k cap, everyone knows, and then b vector will be 4i cap plus 4j cap plus 5k cap. Okay, similarly I will write a2 vector and b2 vector, right? So now we know the shortest formula is this, shortest distance formula is this. Okay, so I need to find a2 minus a1, the easiest one I'll find first. So I have written a2 here, a1 here, subtracted, I got this. Then I will find this and then find its modulus. Okay, see here, b1 cross b2, how do we find? Cross product we know, ijk, and then we write the direction ratios. Similarly we solve and then get b1 cross b2. Now we need to take the modulus. How do we take the modulus? Magnitude, finding magnitude. So square the direction ratios and then add them. Yes, so after that we will substitute in the formula, distance formula. You substitute, this is my b1 cross b2, this is my a2 minus a1, this is my magnitude of b1 cross b2. Once I simplify, I get this. Don't forget to write units because it is length. If it comes negative, you can see here it is coming negative, so I took modulus and made it positive. Okay, now this is another example which you can do it yourself if you wish to. Similar way. Okay, similar way you can solve it. Okay, now let's see shortest distance between two lines, two parallel lines. Okay, two parallel lines is much easier because the lines will be lying on one plane. They will be lying like this, parallel. So they will be parallel like this. Okay, so they will be lying on one plane only, so you don't need to worry. Here you will be able to see the angle nicely. Now I took two equation of the lines, a1 plus lambda b1, a2 plus this, please change it to mu b. Okay, so the first equation is a1 plus lambda b and second equation is a2 plus lambda b. Why I have taken b as same in both? because they are parallel. If they are parallel, they will be parallel to a vector, only one vector. Okay, so see what I have drawn here. This is my line 1, this is my line 2, and this is my 3-dimension axis. Okay, those things are not required because they are in one plane. Okay, only one plane, so we don't need that. So see here, this is my line 1, this is my line 2. Similarly, the point on line 1 is a1 and point on line 2 is a2 according to these two equations. And you see there is only one vector which is parallel to both of them. That's why we have only b here. Understand? Okay, now we need to find this pt, okay, which is the shortest distance between these two lines. Now as I said that L1 and L2 will be coplanar. They will be lying, see, this is my x y z axis. Okay, they are lying on this plane, right? So that's why we are calling it coplanar. The TP is perpendicular to L1 and L2. This we all agree from the last also, and now also you understand. Now see, TP is the shortest distance. If it is perpendicular, TP is the shortest distance between them. So let the magnitude of TP be D. Okay, like last time we took PQ as D. So I am taking TP as D. So now theta is the angle between ST and B. Now see, why did I say ST and P? This is our ST and this is SP. But SP is also parallel to BQ. So what I am doing, I am finding the angle between ST vector and B. Okay, just for just to make it easy to solve, that's why we are using B instead of SP. Okay, if I take SP, I will not be able to find SP. Okay, so that's why I'm taking B vector. So I take cross product of B and ST. You see here, B cross ST. So from here to here, we will have a vector going up here. Yes. So this vector will be written as B cross S. If I say B cross ST, this will be, according to cross product, how do we write? If we have the vector, then we do modulus thing. Okay, if we don't have that, what do we do? B vector ST vector sine theta n cap, right? We do this, so I will be writing like that. Now you know what is our ST. ST, look here, ST A2 minus A1, right? So I have written ST as A2 minus A1. Okay, we know ST, we found it like this. Sine theta we need to find. Okay, n cap, when we take magnitude, n cap will be 1 because it is a unit vector. Okay, now let's see what we can find. Let's find A2, ST we have already found. Let's find sine theta. So let's go to the diagram. You see in this triangle STP, sine theta will be what? Side opposite by hypotenuse. So this is side opposite, this is our theta, this is side opposite, that is TP by hypotenuse is ST, right? So I can say TP is equals to ST sine theta, right? Or I can just write sine theta as this. Okay, so see, sine theta is equals to PT or TP or PT are both same. Okay, because it's the magnitude, so minus doesn't matter even if it is a vector. Okay, in magnitude sign doesn't matter. So now PT can be written as ST sine theta. So here you can see, substituting 2 and 3. 2 is here, 2 is here, this is 2, this one, and 3 is this one. Okay, we will be substituting in 1. And see what is our 1. Okay, now see, our ST was this. Okay, and you can see here I have ST sine theta. ST sine theta. ST sine theta is what? ST sine theta is PT. So here I have written PT in place of ST sine theta, and B has come just like that, and N cap is 1, so we will be ignoring it. Now this is modulus of B, this is B, so I want to find this D. Magnitude of PT already we have written as D. Okay, so we substitute everything. I need to find D. B goes there. So B goes there, you see the formula comes out to be this. Okay, if you are copying, it will be easier to understand. Now let's do an example on this. Now see the shortest distance between two lines. These are in vector forms now. Okay, so this is my A1, this is my B1 vector, this is my A2 vector, this is my B2 vector. Okay, but you can see here that these two are same. So if these two are same, then you can say these two lines are parallel. These two lines are, you can say they are parallel. Okay, so now see, B is this, so we concluded L1 is parallel to this. Now for parallel we have formula. Don't confuse with this cross. You know how crosses come, and two skewed lines, it is dot. Yes, so don't confuse. So we need to find A2 minus A1 as usual. So you know how to find that, and then you find B vector, magnitude of B vector, which is easy to find. First find the easy things, then find B cross A2 minus A1 is this vector, and B vector is there to find. So we got this. Okay, so remember here you have to take cross product in parallel lines. And then from formula the numerator is B cross A2 minus A1 divided by the magnitude of B. So magnitude of B we got as 7. So once you got this, this is not the answer, because you have to take the magnitude, because we are talking about distance. So you need to find the magnitude. How do you find magnitude if a vector is given? You square the direction ratios and add them and take the square root. So this is what I have done. 9 minus 9 by 7, 14 by 7, 4 by 7. Okay, I didn't cancel 14 and 7 because the denominator will be 49 for all of them. So you can see you got the answer as this. Okay, so next I will be giving you the exercise solved. Okay, till then finish these topics nicely, and during exam if you have any problem you can go through these videos very easily. You'll be able to understand.